Dear students, continuing with our lecture series on medicinal chemistry, this is our 27th lecture and this is fifth lecture on antibacterial drugs. In the present lecture, we will discuss about chemistry of sulfonamides and how these can be synthesized. Sulfonamide drugs, basically, these are a group of broad spectrum antimicrobial drugs which are very effective against gram positive as well as gram negative microorganism. So because of their activity towards all types of microorganisms, they have been classified in the broad spectrum category of antibacterial drugs. These drugs are basically derivatives of sulfonamide, that is para-amino benzene sulfonamide. Now, if we see the chemical structure of this molecule, the chemical structure is similar to PABA, that is para-aminobenzoic acid. If we replace this uh, carboxylic acid derivative by sulfonamide, then we can get these types of drugs. And importance of sulfonamide drugs is that if you see that PABA is part of the folic acid. So basically para-aminobenzoic acid is a component which is necessary in bacteria for synthesizing folic acid, because folic acid uh, cannot be synthesized by animal cells by themselves, and it must be obtained through consumption of food. So therefore, when this folic acid is synthesized, one part which is required is para-aminobenzoic acid. And as I have told you that sulfonamides or sulfonamides, they are structural analogs of PABA. Now, uh, when we add these drugs, sulfonamide drugs, then as I have told you, they have a structure similar to para-aminobenzoic acid. Then that sulfonamide will compete with the para-aminobenzoic acid for inclusion into the molecule of folic acid. So if instead of this amide linkage, we will have sulfonamide linkage in the folic acid which has been synthesized due to the presence of sulfonamide drugs, and because of this a false molecule of folic acid will be synthesized in the bacteria, and that false molecule of folic acid will not be able to carry out the vital function of true folic acid, and that is how these drugs, they will be effective against many types of gram positive and gram negative bacteria. Now, as far as classification of sulfonamide drugs is concerned, there is no systematic way of nomenclature or classification, and they have been classified in two ways. One is systematic, that is their absorptive action, and other is their local action. As far as systemic classification is concerned, they can be divided into short lasting, moderate lasting, and long lasting sulfonamides. In the category of short lasting sulfonamide, sulfastine, sulfadiazine, sulfamerazine, sulfamethoxine, sulfamethiazole, sulfa-isoxazole. So all these, they are under the category of short lasting sulfonamides. And moderate lasting is sulfamethoxazole, sulfapyridine. These are the category of sulfonamide drugs. They will last moderately in the cell. The long lasting is sulfamethoxypyridazine and sulfamatter, which can be considered as long lasting sulfonamide drugs. Then there is another classification which is based on the local use of these drugs. And if this use is ophthalmological, that is concerning the eyes, then these are the two examples: sulfastamide and sulfoxazole. Then if vaginal use is there, sulfabenzamide, sulfastamide, sulfathiazole, sulfisoxazole, these can be used in vaginal diseases. Then for external use, mefenid, sulfur, sulfadiazine, they can be used in the external in the form of paste and other things. Now, synthesis of some common sulfonamides. First example is sulfacytene. Sulfacytene is synthesized by reacting 4-acetyl aminobenzene sulfonyl chloride with 1-ethyl cytosine. Uh, the 4-acetyl benzene sulfonyl chloride, when this is reacted with the 1-ethyl cytosine, uh, we will get these types of sulfonamide derivatives, and these sulfonamide derivatives on reduction in presence of zinc, sodium hydroxide, this acetyl bond will be hydrolyzed or reduced to give you sulfonacetyl. And this 1-ethyl cytosine, this can be synthesized from 3-ethyl aminopropionitrile. When this is reacted with the cyanic acid in presence of hydrochloric acid, this gives us this type of ethyl urea derivative, and an ethyl and 2-cyanoethyl urea is formed, and this in the presence of a strong base like sodium methoxide in HBr undergoes condensation and cyclization. So because of the presence of this cyano group, these hydrogens present at this carbon, they are acidic in nature, and they can act as active methylene group, and a condensation can take place over here to give us these types of dihydrocytosine derivatives. And these dihydrocytosine derivatives in presence of bromine, they can be converted into this type of first hydrobromide will be formed, and then dehydrobromination will take place to create this carbon-carbon double. And these sulfonamide drugs, they are effective for infections caused by streptococci, gonococci, pneumococci, and staphylococci. Then these are used for pneumonia, cerebral meningitis, staphylococcal and staphylococcal sepsis, and other infectious diseases. Next is sulfadiazine. Sulfadiazine is this drug. This is basically a derivative of 4-amino sulfonamide. So first is uh, when 4-acetyl aminobenzene sulfonyl chloride is reacted with 2-aminopyrimidine, basically hydrogen from here and chloro from here, HCl will be removed to give us this type of pyrimidine sulfonamide derivative, and then zinc acetic acid reduction of this will lead to the formation of this amino group to give us this type of drug, sulfadiazine. Next is sulfamerazine. Sulfamerazine, again you can see this is similar to the previous drug which we have synthesized. Only difference being the substitution at this place. So this is also a pyrimidine derivative, basically 4-amino sulfonamide when reacted with 2-4-methylpyridine. So this is 2-4-methyl pyrimidine, uh, which when reacted with the 4-acetyl-aminobenzene sulfonyl chloride, as we have done in the previous case, you will get the substitution product in the same way. H from here, Cl from here, and sulfur nitrogen bond will be formed, sulfonamide is formed, and then reductive hydrolysis of this will lead to the formation of this. And this 2-amino-4-methylpyridine, this can be synthesized from guanidine and acetoacetic ester. When they condense with each other, we will get these types of pyrimidinone derivatives, and these pyrimidinone derivatives, they will react in the presence of phosphorus oxychloride, and this amide will be converted into halogen derivative, and then reduction in presence of hydrogen on palladium and charcoal will lead to the formation of 2-amino-4-methyl pyrimidine. The next is sulfamethisole. This is the drug sulfamethisole. This can be synthesized by two methods. First method is that when 5 5-methyl 1,3,4 thiadiazole 2-amine is reacted with 4-nitrobenzene 1-sulfonyl chloride, basically Cl from here and H from here. Formation of a sulfur nitrogen bond will take place, and we will get this type of sulfonamide derivative. And then this sulfonamide undergoes reduction of the nitro group in the presence of iron and acetic medium to give us sulfamethisole as the product. Then similarly, the second method is when 4-acetyl-aminobenzene sulfonyl chloride is condensed with acetaldehyde thiosemicarbazone. This in turn is synthesized from acetaldehyde and thiosemicarbazide. So this carbazone, when these are condensed, H from here, Cl from here, again same type of sulfonamide will be formed, and then in presence of potassium ferrocyanide, this will undergo cyclization to give us this thing, followed by hydrolysis, reductive hydrolysis of this group to give you amines. And this drug has antibacterial activity with respect to many type of microorganism, as you can see bacillus, staphylococci, pneumococci, streptococci, all type of bacteria, they can be affected by this drug. And this is generally used for acute and uncomplicated infections of UTI. Then synonyms of this drug, this is also known as urosol, rufol, and thiosulfil. The next is sulfioxazole. Sulfioxazole, this is again a similar type of sulfonamide derivative, and this can be synthesized from 4-acetyl-aminosulfonyl chloride on reaction with 1,2-oxazyl 5-amine. So when this is reacted with this in the same way, H from here, Cl from here, sulfur nitrogen bond will be formed. We will get this type of sulfonamide derivative, and then hydrolysis, acidic hydrolysis in presence of HCl. This acetyl group will be hydrolyzed to give you amino group, and we will get self isoxazole as the product. And this 1,2-oxazole 5-amine can be synthesized from the condensation of 2-methyl 3-oxobutane nitrile with hydroxyl. Again, this drug is effective in treatment uh, caused by infections caused by streptococci, gonococci, pneumococci, staphylococci, and colon bacillus. And the other names of this drug is gantrizin, fultrexin, sulfazine, and sulfolol. The next is sulfadoxin. Sulfadoxin is a sulfonamide drug synthesized from these types of pyrimidine derivatives. So the basic formation of this drug can be achieved when we start with methyl methoxyacetate reacts with dimethyl ethane dioate. So condensation will take place in the presence of basic medium. So this will act as an active methylene compound. This will attack this carbonyl carbon with the elimination of H from here, methoxy from here. Methanol will be removed, and this type of you can say addition product will be formed. Dimethyl 2-methoxy 3-oxobutane diode will be formed, and then this compound undergoes reaction with ammonia to give us these types of 2-methoxypropane diamide derivative. And this uh, methoxy 2-methoxypropane diamide undergo heterocyclization on reaction with formamide in presence of sodium methoxide to give us this uh, 4,6 dioxy 5-methoxy pyrimidine derivative. And this 5-methoxy pyrimidine 4,6 diol on reaction with phosphorus oxychloride, both these hydroxyl groups, they will be converted into chloro groups in presence of phosphorus oxychloride. And then in presence of ammonia, one of the halogen group will be selectively converted into amino group. Then in presence of sodium methoxide, here nucleophilic substitution will take place, and this halogen will replaced by methoxy group. So Na from here, Cl from here will be removed, and this is the pyrimidine amine which will react with the 4-acetyl 4-acetyl benzene sulfonyl chloride, and again H from here, Cl from here, and sulfur nitrogen bond will be formed. We will get these types of sulfonamide derivative, and again this part will be hydrolyzed in presence of sodium hydroxide, and we will get sulfadoxin as the product. Then is sulfolane. Sulfolane is again this is a pyrazine derivative of sulfonamide, 4-amino benzene sulfonamide. So when pyrazine 2-amine is reacted with bromine in acetic acid, bromination will take place at these two places, and we will get 3,5-dibromopyrazine 2-amine. And when this is reacted with the strong base like sodium methoxide, one of the halogen will be replaced by methoxy group. And then this bromine is replaced by hydrogen in presence of hydrogen on palladium and charcoal, and this is our one of the starting material 3-methoxy pyrazine 2-amine, and this will condense with 4-acetyl amino benzene sulfonyl chloride. So Cl from here, H from here, HCl will be removed and nitrogen sulfur bond will be formed. We will get this type of pyrazine sulfonamide derivative, and then this group will hydrolyze in presence of either acidic conditions or basic condition, and this will be converted into an acetyl group will be converted into amino group. So sulfolane is very important sulfonamide drug which is used as a bacteriostat, and it has a broad spectrum of antimicrobial activity. And this drug binds to protein in the plasma to a lesser degree than the sulfonamides, which ensures high concentration in the blood in a free form. So, therefore, only one dose of sulfolane is needed to be taken per week. This drug is also known as sulfizine or sulfamethopyrazine or sulfamethoxypyrazine. So these are the references which have been used for preparing this lecture. Thank you very much.